Hi, welcome back. In this video, we're going to talk about how to describe the end behavior of a polynomial. So let's say that we're given a polynomial that looks something like this, right? Our goal is to talk about what happens as the arrow goes towards the left and as the arrow goes to the right? What is the behavior of the function as x increases to the right or as x decreases to the left? And to do that, we're going to introduce this new notation called limit notation. Right? To describe it, what this really means here is what is the limit of a function as x approaches negative infinity. Meaning, if you look at a graph, this is the x-axis, right? What happens to the function? What is the limit or the behavior? What is the behavior of the function as x gets smaller and smaller and smaller and goes to the negative infinity side? What is the function going to be doing? And similarly over here, right, what is the behavior of the function as x increases to the right? So as x goes bigger and bigger and bigger, what is the function tending to do? Yeah, so you can take all of this and really make it into words. You can say something like, what is the behavior? Or the tendency, if you want, of the function as x approaches. We use the arrow to say as x goes in the direction, right, of infinity. In this case, infinity is on the right side of the graph, right? And over here, negative infinity is on the left side of the graph. So whenever we're given a function, can we describe the tendency of the function? Is the function increasing? Is it decreasing? Right? What is it doing? So we'll do a few examples that will require us to be able to sketch the function. And then from the sketch, we can determine what is the function doing on the right side or on the left side. So here's what I mean. Here we have a cubic polynomial. Now, because it's positive cubic, as you saw in our previous video, right, with sketching polynomials, you can see that this function is going to cross through -2 as our y-intercept. And because it's increasing, it's going to have 1, 2, 3 different directions it's going to flow through. Positive meaning it's increasing in this direction, right? So now we can describe the tendency of the function. What happens to the function as x goes to the negative side or the left side, right? As x gets smaller and smaller and smaller in this direction, the function is going downward to negative infinity. What is the function doing as it's going to the right? Well, as it goes to the right, the more it goes to the right, the higher it goes to the positive infinity, right? So we're really looking at describing the end behavior. What happens on the ends, on the right end and on the far left end, right? Can we describe the behavior of a given function? Here we have a polynomial to the fourth power, and since it's positive, we know that this polynomial has a y-intercept of -12, so it'll go through here, right through that point. And since it's a positive, it's going to be pointing up. It'll look like a W, something like this. This is just a general sketch, right? This allows me to determine the end behavior. What happens on the left side of the graph? As x gets smaller and more and more and more to the negatives, the graph is pointing upward to positive infinity. Yeah. And what happens to the function as x goes to the right? This is the positive side. As x increases, it'll go up and up and up to also positive infinity. So if we know how to sketch a general polynomial, whether it's positive or and a little bit of negative, we'll know the direction of the arrows, and that's really what determines, right? This is the left side of the graph. This is the right side of the graph. It allows me to determine where the arrows are going eventually. There's a lot of things that happen in the middle, right? But as it goes to the right, it'll eventually go to infinity. And on the left, eventually it'll go to positive infinity as well. So try these out, right? Give them a try, draw a sketch, see what you think, and see if we come up with the same solution. This is a negative cubic, right? This one also goes through -2. But because it's negative, meaning it'll eventually go to the left side or to the bottom side. So this one will look something like this. The negative cubic, right? It'll eventually go to all the negatives. So what happens on the left side? The left side of the function will eventually always go to positive infinity. And what happens as the function increases to the right? This is the right side. As it goes to the positives, the function will eventually just decrease to negative infinity. Yeah. We're describing this part of the graph and the right side of the graph. What does a negative to the 4th power look like? And it goes through +2. Well, if it goes through +2, it crosses through here, and because it's negative, it'll look something like this. Right? It's going to point downward. It's got 1, 2, 3, 4 different paths it's going to go through. What happens on the left side of the graph? Well, on the left, as x decreases, it'll eventually go to negative infinity. And on the right side, what happens as x increases, it'll also go to the bottom, which is negative infinity. Yeah? So, when we're describing the end behavior, we want to be able to do a sketch. Do you know what the general polynomial does? We don't need to know the specifics, right? Like the x-intercepts. We don't need to know anything like that. Just a general graph will allow us to determine the number of paths it goes through, and then the sign in front of it, the leading coefficient, tells us the direction of the path, right? Are they pointing down? Is it pointing up? And then we can describe it with infinity and negative infinity. Those will really be our only two options. Is the function going up, or is the function going down towards the negatives? Alright guys, I hope this has helped. Please let me know if you have any questions. Don't forget to like and subscribe, and as always, I'll calculate.